guys think?
Engineering! Arts and math! Steve is awesome!
Welcome to our second annual STEAM Fair, sponsored by the UMass Lowell Chemical Engineering Department. We are so excited to have all of you here. We have 32 participants, our kindergarten through fourth graders.
Tell me about this, Freddy the Fish. What is this about? Keeping our oceans clean?
It's about keeping our oceans clean so all the animals in the water don't die.
And what's making our oceans dirty? It looks like you have a whole bunch of things here, don't you?
Like fertilizer, salt, litter, acid rain, oil, and all kinds of stuff like that.
Ah, and who's responsible for this?
I am.
You're-
my sister,
Oh, you both did this. And what's your name?
Mallory.
Mallory. Good to have that. Okay, so we need to keep our oceans clean from all these different pollutants, correct? Do you know how we can do that better?
We can do it by taking care of the earth on Earth Day with throwing things in the trash and the recycling bin where it belongs.
So that's very good. And when was Earth Day? Just recently, wasn't it?
It was last Saturday.
Last Saturday. That's very good. So what do we have over here? We have some acid rain. You know what causes acid rain? No? It's actually caused by pollutants that go up in the air, like from certain types of, when you burn things, you don't burn it completely. That goes up in the air, and then that forms with the chemicals up there, and it causes acid rain. And do you know what acid rain does then? Nope. Do you know what acid rain does to our plants? It kills them. That's why we need to get rid of that. All right? Well, this is very good, and I thank you very much. You are doing Little Einstein's exciting science experiments for kids. What are some of these experiments we can do?
Like, we could do fireproof balloon, amazing paper bottle in a bottle, water sucking glass, and water fountain.
Okay, now you gotta tell me something about it. How do you get a glass to suck water?
By putting some water on the plate, and when the candles light up, you put the glass, and the pressure outside will push the water inside, and the pressure inside will push it into the candle, and it will make it like go off, and the temperature, the height of the water will be very high that there's not much water here than there is here.
Okay, so I see that you're set up maybe to do this right here. How long does this thing take to suck up all the water?
It takes like maybe 5 or 10 seconds.
Whoa. Are we ready to actually show that, or? Yeah. Okay, let's do that. All right, so we are lighting the candle.
And we will see it.
You show this one.
They show this one.
Yeah.
So,
Show this.
so that, you put that over the top, and that's all the water's gonna get sucked up now, because it's gonna heat it up. I do see the water seems to be lowering, yes. Oh, we lost the flame though. We lost the flame.
Yeah.
That experiment was not a successful one, at least the first time.
Just a little bit.
Yep, just a little bit. But thank you very much. All right? This is a very interesting, not just one thing, but 3 or 4 different ones, right?
There's like 2 pictures of one of it, which
Yeah.
is water sucking glass.
Okay, well, thank you very much. The big question on your sign is, does toothpaste work?
Yes.
And the answer to that question is?
Yes.
Yes. So how does it work?
You gotta put toothpaste on it?
Well, let's I see. What does a toothpaste do? You put the toothpaste on your brush and you brush, and that gets rid of what? It gets rid of all the stains on your teeth.
Yeah.
And I see up on your sign here, you have different types of stains that can go in your teeth, like coffee and soda and juice. Do you drink coffee?
No.
Oh.
I don't drink any of them.
So that's actually the coffee stains are adults, right?
Yeah.
Yeah, okay. So if you use toothpaste, it gets rid of the stains, right? Okay, and what do you have here now? You have different cups with different types of things, right? What do we have? Oh, we have it. Oh, I see. These eggs represent your teeth, right?
No.
No, they don't? Well, I can see something here that this coffee egg has a lot of stains on it, right? And if you have it with toothpaste, it has a whole lot less stain, correct? That's very good. Now, the question I'm going to ask, just to make sure, and you do brush your teeth every day?
Yes.
Yes. And now it's on TV.
No.
Yes, it will be. All right, thank you very much. This is Charlie Miranda, and he is talking about how to make milk into plastic. Is that correct?
Yeah, and how we made it is those are the instructions, and we used it in the oven, and we used the milk and that's my list.
Oh, go ahead. So you have 10 steps to do this, right?
Yeah.
It looks like it involves vinegar.
Yeah, vinegar
And heating it
milk,
up.
and then we squished it, and then we made it like a brain, and then we mixed it, and then we put it in milk, and we put it in vinegar, and we put it in milk, and then we have the vinegar in milk, and then this is what it looks like when we mixed it together. And we put a towel on it, and this is what it looks like.
And that's what it looks like after 2 days.
Yeah.
The milk and the vinegar turned into a plastic coat. Is that what it looks like? It looks like a coat or a jacket, doesn't it? Now, how big is that? It looks like it's really small. It's not one you can wear, can you?
No!
No, I didn't think so.
Imagine it was too big. It was too big. That I wouldn't like that I would have a big picture of it.
Yeah, well, this is very fascinating. I did not know that you could make plastic out of milk and vinegar. So I learned something today.
What?
But that's just that. You can make plastic out of milk and vinegar. And I'm a chemical engineering professor, and I didn't know that. But thank you very much, Charlie. This was very interesting. This is a box monster. So tell me about this box monster.
Well, me and my mom decorated it on the back and the inside, and you're basically supposed to there's the different flavors, and you sort it.
Ah, so depending where the food goes into his mouth, he tastes different flavors, correct?
Yeah, and you sort it.
Ah, so you're just putting potato chips. You're putting potato chips back there into the salty part of the mouth, right?
And this would be
And where is the sweet part of this mouth?
right here.
Right up front
I should
there.
make the sweet bigger because there's a lot of the sweet ones.
Ah. So I didn't know that your mouth has different parts of it. So when you taste food, it's in different parts of your mouth?
Well, it's more on different parts of your tongue, just they didn't have room, so
Ah, so it's the tongue that is the taster.
yeah.
That's very interesting.
I didn't have enough room.
Yep.
So.
All right. This is Brooke, and her project is all about
Zebras.
zebras. Okay, tell me about zebras.
Zebras make their own air conditioning, and they have 2 stomachs.
2 stomachs? Does that mean they can eat twice as much?
It just helps them break down the nutrients.
Okay. And And you told me, you just said that they have their own air conditioning. How does that work?
Black stripes absorb the heat and white stripes reflect the heat, and it makes an air conditioning for zebras.
So the coloring of the zebra has a purpose.
Yes.
Very good. So what do you all have here? What do you all have here now? Well, wait a minute. This book, Who Scoops Elephant Poo Working at a Zoo? What's the answer to that question?
The zookeeper.
The zookeeper, okay. So, why did you pick zebras? You like zebras?
Yes, I thought they were an interesting animal.
Okay. Very, very good. And I assume you've been to the zoo and seen them already.
Yes.
Good. All right. Well, thank you very much. This is very, very fascinating. And I learned something. I learned that they had two stomachs, and I learned they carry their own air conditioner on their backs because of the black and white stripes. Even I'm a professor at UMass Lowell, can learn something from you. So congratulations. Thank you very much.
You're welcome.
Here we are with Austin. Your project is called the Volcano Experiment. What is this about?
It's all about chemistry, and I'll show you how it works.
You're gonna show it to me right now?
Yes.
Okay, this sounds good.
And the vinegar acts as an acid, and the baking soda acts as a base. And an acid mixed together, and also a base causes it to erupt.
So you're gonna put the ingredients into the volcano.
I'm gonna add 1 spoon of it.
1 spoon of baking soda. Nope, 2 spoons of baking soda.
Yes. After that, I'll add 1 spoon of dish soap.
All right. A spoon of dish soap.
I'll start pouring it into the volcano, like so.
And now what else?
I'll add in a bit of warm water.
Adding some warm water.
Then after that, I'm gonna add the vinegar.
And now we are adding some vinegar. Whoa! We had an eruption, didn't we?
Yes, indeed we did.
Wow. All this from stuff you can get in your house.
Yes.
Whoa.
I
That
know.
is neat. Now, how did you learn about this?
I watched a video on an app called YouTube, and I saw how it works.
Well, this is fascinating. Just using chemicals that you can find in your kitchen, you've made a volcano.
Yes.
Congratulations. This is Finnegan, and your topic is, what if the Earth stops spinning?
Yes.
So what happens?
Half of the Earth would be freezing, while the other half would be 10,000 degrees Celsius.
So half the world would then get very hot, and the other half get very cold.
Yes.
Do we know a place that already is like that?
Yes.
What's that?
Antarctica is very cold, and then the African savanna the desert and the African savanna are very hot.
Okay. But I also know of a place that's near us that has the same thing. One side's always to the sun, and one side is always to the back. You know where that is?
The middle of the Earth?
Nope. Something up in the sky you can see at night.
The sun.
No, at night.
The moon.
The moon, that is correct. What you just described, if the Earth stops spinning, the moon doesn't spin. It does a little bit, but it's basically spinning the same speed as it goes around. So that means one side of the moon is always hot, the other side is always cold. Now, you don't really know it because there's no air up there, so you can't really feel it. But that's what would happen. This is fascinating. Where did you get this idea?
I I tried to think of projects to do, and I thought about like the planet because I got distracted. Then I thought, why don't I do what if the Earth stopped spinning?
Well, that's very, very good. This is Gregory, and your project is the physics of a catapult. So tell me about how does a catapult work?
So we have the weight at the bottom. You can see right here. Not very good seeing this. Anyways, so then we have the scoop at the top, lever, tape, pivot, body, and we already went over this, the weight. Then we have like this, so you all know exactly what the main thing is all about it. So we got plan, do, check, and act. And then we have like the real version working on it right here. And then we have the test, which is the prototype, which didn't exactly work.
Why didn't it work?
Well, we had an issue because like it didn't stay on for that long because the glue wasn't holding on to the cardboard.
Okay. So, actually, you learned a very valuable lesson that engineers and scientists learn. Not everything works the first time. Which means what? We have to find out why it didn't work and then figure out how to improve it. It sounds like you're an engineer already. You did that. Right?
Yep.
So you had a working copy at the end?
Yep.
And how far did it throw the weight?
Pretty far.
5 feet? 50 feet? 500 miles?
I'm pretty sure it might be 5 feet.
Okay. It wasn't 500 miles though, huh? No, okay. That would be a dangerous weapon then, wouldn't it?
Yep.
Okay. Well, thank you very much. This is a model of Chelmsford. So tell me about this.
So this is just the school, and it says school, and there's a sign, and it says Harrington School, and there's another sign, and it says Chelmsford, and this is a blue building. It's a college for teenagers, and there is one small tree there, and another one there, and here is 4 houses, and I have 3 neighbors, but the reason is why there's 4 houses is because one of them are going to be mine. So this is mine, and this is the others, and the others, and the others, and this is the hospital there, and this is a restaurant, McDonald's.
Okay, so what gave you this idea to create this model of Chelmsford?
So I tried to create this. My dad helped me only a little, and I did what he asked.
Well, this is very interesting. And you actually, you said this was your house, right? So thank you very much. Rob, okay, and this project is parachute flyers. So tell me about this.
So I created a bunch of parachutes out of plastic bags, and I created 3 of them, and this one was good, but I wanted to create a better one, so I made this one bigger, but it was worse. So I figured out that I made this a lot heavier. And then on my last one, I made the cup a lot lighter, and I made the top a lot lighter too. So now it goes really slow, and it's a great parachute.
So if I see here, you took 3 different examples, right? 3 different samples, and did 3 experiments, right? And they were different. Were they all the same experiment done 3 times, or 3 different experiments?
The same experiment done 3 times.
And I can see you're a scientist already, because I see you did 3 experiments, which is always what scientists do, and then you have different results because things don't always work exactly the same. And it looks like experiment 3 went the furthest. Is that right? Okay. Now, how does a parachute work?
So like the air, since the top's really wide, the air like so that it takes less time to reach the ground.
And that's important when people jump out of airplanes with a parachute, right? So they don't get down to the ground too fast. Well, this is very interesting, and I particularly like how you did multiple experiments and then got different results, which always happens. And I will tell you, I'm a professor at UMass Lowell. We have our students do multiple experiments, and then they have to figure out why this maybe one experiment didn't work like the other ones did. But that's part of becoming an engineer or a scientist. So you're becoming one already, and that's excellent. And you're only in 3rd grade. And you did probably better than some of my students did.
Thanks.
Yes! Oh, and now we're gonna load up the person inside the parachute. Very, very good. Tornado in a bottle. You gotta explain this to me.
Well, a tornado in a bottle is an experiment based off of a vortex in a bottle. The vortex is the tornado. A tornado is a type of vortex, and for this bottle, I used a large hole for this one. For this one, I used a medium-sized hole. This one, I used a small-sized hole.
And which one creates a better tornado?
The one with the large hole, because it has better ways of showing air go up and water go down.
Okay. So why don't we demonstrate this? I'll move my arm out of the way. Go ahead and demonstrate. Whoa!
This one actually works pretty cool. This one I like most, but this one works the best. If you watch this part, it's a fountain.
Yeah, but look up there. I can see a tornado in the top part. That is so neat. Now this is a small one, huh?
Yeah, it doesn't work at all. This
Yeah.
one doesn't work because it has a small hole. So you can tell because air tries to go up and water tries to go down at the same time, but it's not big enough so both can go down and up.
So in a real tornado, that's what's happening also. It's spinning because some of the air is coming down and some of the air is going back up, correct? And that then starts spinning. That's excellent. I did not know you could make a tornado in a bottle. I have learned something else again tonight. So thank you very much. Perfect dojo. You gotta tell me about this.
So I've been going to a dojo for about 7 years, so I wanted to create a more eco-friendly version for it to be more safe for the earth.
And just so everyone knows, so some people may not, a dojo is for what?
Practicing some type of karate.
Okay, thank you. I had a son that did karate also, so I knew that, but maybe not everybody did. So I thought we'd explain it. So, what is your eco-friendly dojo made out of?
Well, I have some bamboo wood and some vinyl for floors and carpet, and white brick on the outside to reflect sunlight, and some plexiglass for the windows because it can bend more than normal glass, so it's safer.
All right. Well, thank you. So, is the dojo that you go to going to adopt your suggestions here to make it more eco-friendly?
Well, I told the office lady about that, and she was like, okay, I'm probably going to put some plants in the dojo.
Okay, well that's a start, right? You have made an influence. Congratulations. Why did you pick this project?
Because I'm really interested in airplanes and I want to know how it works, so I decided to make one.
I assume you've been on an airplane before?
Yeah.
Have you ever been in a glider? Yeah. What's different between a glider and an airplane?
An airplane, it's like normally for a lot of people, and a glider, you don't hear it much often.
And the other major difference is an airplane has engines, glider doesn't. So you have to stay up there. So is that why these wings are so much bigger?
Uh-huh.
Now, have you actually tried to see if this one works?
Yeah, it
And
kind of works.
It kind of works?
Yeah,
Does it
just
stay
for
up?
a little while.
Oh, okay. You need to get on a high hill with some wind. Then it would work better, probably, right? Okay. Well, thank you very much. Tell me about this.
I chose to do this because we had done it for our second unit in science, and my mother told me about the science fair, and she was like, "You can think about your project," and suddenly it just popped into my head like, "Oh, I can do this."
Okay.
So I decided that I would do what materials conduct electricity because I knew about it, and it would be like fun to research. So yeah.
So, how does electricity work? I think you have some of those answers up here.
So most wires are made out of copper, which, if you look up here, does conduct electricity. And we asked questions like what non-metals conduct electricity, what kinds of metals conduct electricity, and why do some materials conduct while others don't. We looked at the anatomy of the atom to figure out what electrons were as a bonus, and we came to a conclusion about what we learned about and what we researched and what I was surprised about. So yeah.
All right. So, obviously you figured out that metals conduct electricity pretty well. What is something that is not a metal that also conducts electricity?
So I think the most interesting one was salt water. So we have the battery, the wires, and the light as the visual, like it conducts electricity. So we have two conductors here going into the water, and we put them here, and the light lights up, which is weird because distilled water here barely does anything.
Yeah.
And salt doesn't do anything at all.
So, it's the salt in the water that makes it work. Salt by itself, no. Water by itself, no.
Yeah, pretty much.
That's a very good conclusion. Let me see how this works.
Need to set up these dominoes.
It's nervous when you're in front of the TV, aren't you?
Yeah, it's my first time, so. I think my sister's been on TV before.
That one doesn't want to stand up.
Yeah, I'll just switch it with this.
Yeah. There we go. All right. We are.
Almost. I'll try again.
Oh, first attempt. Almost. This is part of being a scientist or an engineer. It doesn't work all the time, and when it doesn't work, we have to figure out why and try to improve it. There we go. All right, we're setting it all up again. Take your time. But let me describe, while she's setting this up, let me describe. Looks like if we knock down all those, it then makes this thing jump down, crosses the thing across, and then hits the button and turns on the coffee machine. Whoa. All right. Now, hang on a second here. Did you do this because you like drinking coffee?
Yes.
You do drink
Yes.
coffee?
Yes.
Aren't you a little young for that?
I don't think so.
Actually, let me tell you something.
So my dad was ordering me a piece of coffee, and it was supposed to be a tall from Starbucks, and he get a venti, doubled it by accident, and he didn't even put it decaf. And then I had a hockey game. I drank it all. I was shaking the entire game.
And what age was that?
It was this year. I was 9.
This year. Well, I'm going to tell you a secret. My wife, who is also walking around here, started drinking coffee when she was 5 years old.
Oh, I started when I was 3.
Yeah, that's very early.
Yeah.
All right, we're getting it set up. One more try. All right, let's try this. Ready? Oh, okay. Just like it. When you're on camera, it doesn't work.
Yeah.
Well, thank you very much, okay? Tell me about this. Things that sink or float.
Okay, that my process is sink or float, and this is speaker A, and this is speaker B, this is egg 1, and this is egg 2, and I want to put egg 1 in speaker A, and this doesn't have salt, and this has salt, and do you think it'll sink or float?
This is the salt?
No, this is not the salt.
This is not the salt, and that is the salt.
Yeah, do you think
Okay, I'm going to say it's going to sink here.
It sinks.
I was right. Will it sink over there?
Let's check. Do you
Let's
think
check.
it'll sink or
Well,
float?
salt water is more dense, so it might not sink over there. Let's see.
Do you think it floats?
I think it will float.
Okay. It
It
floats.
floats. Now, what's the difference? One has salt in it and one doesn't, right?
Yeah.
So what did that change?
Because the salt has more dense and it makes it push it higher, and this doesn't have much dense, so it'll go lower.
That's absolutely correct. The salt water is a higher density, so things that can float there but will sink in regular water.
Yeah, and now I want to put the boiled egg inside. Okay?
All right.
I'm trying to put this. Okay. Do you think it'll sink or float?
I'm going to guess it's going to sink.
It floats.
No, it floated.
Do you think it'll sink
Well,
or
if it
float?
floated over there, it's going to sink over here.
Yeah, it's sink.
Yes, all right. Well, this was very interesting. Thank you very much.
You're welcome.
A boat craft. Tell me about this.
My first one is, it says abstract, and it says, can I make a boat that can float? Ask to find out. Question 1, how will it float? Question 2, can it move? Hypothesis, I think my boat will float. I think my boat will move. Background research, YouTube videos, materials. 3.5 popsicle sticks. We use 2 kinds of glue. My mom helped me use the hot glue. And then on this boat, I burned my finger by myself.
You did?
Yep. And then the other one, my dad helped me with the Gorilla Glue.
All right.
And then we used 1 rubber band.
The rubber bands for the propulsion, make the boat move?
Yep, for the bottle caps. And then we use scissors, and then the bowl of water. And then it says, goal, make the boat move and float. First try, sink or float. It floated, but it didn't move.
All right.
The second boat, second try, second sink or float. It floated, and they were these big popsicle sticks. And then it moved too. And then third try, sink or float. It floated, but it didn't move. And those were the little popsicle sticks, which is that one.
Okay.
And then fourth try, sink or float. It floated, but it didn't move. And then after it's this one, my boat I use these for like the blue and the red are the long ones, and then the circles are supposed to be green, and then those are the bottle caps, and then these are like the raft, and then down here it says key, and then these circles are the bottle caps, and then the dotted lines is the rubber band, and then that long line is the propeller. And
So show me if it was, that's your boat right there, right?
Yep.
And you have water here.
Yep.
So you can see, you can show me if it works or not, right?
Yep. And
Show it to me.
this is the last one.
Yeah.
Conclusion. I was able to build a boat that moved and floated.
So show it to me here. We're gonna wrap up the rubber band to make it propelling it. Okay. We're getting the engine primed. And oh, let's try that again. Really wrap it up really good and tight.
You don't want to wrap it up too much or
It breaks.
Yep.
Oh. All right, let's see if it works. Uh-oh.
That's too tight.
Okay.
Dada.
Either use your boat that works, and then do you remember which way you're going to pull it? Right, to make it go forward, or you're going to pull it back?
This one works better than that.
Okay, let's see this one. All right, let her rip. Whoa, it does move. It ran into the side, but it moved. Congratulations. You designed a boat. And what grade are you in?
First.
First grade, and you're designing boats already. That's impressive. We are here now with Sahana, and Sahana is looking at star constellations. And I see some paper cups which have holes in the bottom. I bet you that's to make the constellations, correct? So tell me about this.
So, one fact about constellations is that constellations are named after zodiacs, Greek gods, and mythological creatures. Another fact is that there are 88 officially recognized constellations. The third fact is the biggest constellation is Hydra, covering 3.2% of the sky. And the fourth fact is that the constellation Big Dipper is part of the constellation Ursa Major. And the last fact is that you can find the constellation the Little Dipper by finding the North Star first. And then I have some other facts about specific constellations, like that did you know that the Big Dipper is the Little Dipper can be found in the northern skies, and Orion is called the Hunter and is the most famous for the constellation, and Libra is a zodiac. It is Latin for weighing scales.
So all these are different. You said there was 88 constellations. Is that just in the northern sky, or does that also include the southern sky?
Yep.
It does. Okay. Because have you ever been south of the equator and seen the southern skies?
I don't really know if I have.
I have been down there once, and I looked up at the sky. It looked completely different. That Big Dipper I could not find because it's not down there. So that was interesting to me. Well, this was very good. I enjoyed this.
I can choose.
Yeah, show it to me. Yeah. We got the light here. Oh, there's the Big Dipper, Little Dipper. Which one is it?
This is the Big Dipper.
That's the Big Dipper, okay. And what else we have?
We have Orion.
I would say, now I know Orion had 3 stars that were real close to each other, like it was his belt, right?
Yeah.
Yep.
This is the bow and arrow, the
Yep.
legs, the head and body, and the arms in the sky.
And what else do you have here? Do you have the Little Dipper yet? Or the
The Libra is
Libra.
a zodiac sign, and you can kind of see that this is the top of the weighing scale, and these are like the weighing parts to put things in.
Well, thank you very much. I've learned something also now. I was going to ask you whether I knew like Orion was a constellation. I didn't know if the Big Dipper or the Little Dipper were constellations or just patterns. So I learned something. Thank you very much. We have here Amelia and Alec, and we have something called Yummy Gummy Bear Osmosis. What is this all about?
We were putting gummy bears in different water for 15 hours each, and they were all in different liquids. And we were estimating that they were either going to stay the same, get bigger, or smaller, depending on the liquid they were put in, and we were right. This is tap water after 15 hours, and then vegetable oil stayed the same at 2 centimeters, and our biggest was tap water at 3.4 centimeters.
So they grow if they're in water, but if they're in vegetable oil, they don't grow?
It's depending on the type of liquid for the osmosis to happen. The water we think worked the best because it was the thinnest and easiest to travel through, and we think that the vegetable oil didn't work as well because it was too thick and it was oily, so it couldn't go through as easy.
All right, so does this mean, let me ask you a question. You did this for what, 15 hours you said?
Yeah.
If I go into a bathtub for 15 hours, am I going to get bigger also?
No, because we were doing gummies with gelatin, and they have a semi-permeable membrane, which means a layer of an object that has microscopic holes that you can see, and that's how the liquid traveled through it.
So I don't have to worry about going into a bathtub for 15 hours and getting much bigger, because I don't want to get much bigger. Well, this is very interesting. Now, did you check out whether different color gummy bears had different things, or just...
Thinking of that, but we only did the different types of liquids. I don't think that it would depend on it, because I think that they're all the same flavor. I feel like it's just the smell.
All right. I think you're right.
Yeah.
All right. So you did water, you did vegetable oil. What other liquids did you do?
We did salt water, baking soda, milk, and let me check. So tap water, that got the biggest. Salt water, baking soda, and milk all had similar results. And then we did vegetable oil, that stayed the same, and vinegar.
All right. So water is worse than milk. So this whole idea about taking a milk bath is, I can do that, not get bigger.
The milk fell apart really easily.
The milk ate the gummy bear, huh? Is that what happened?
So after we put it in for 15 hours, it had gotten bigger, but we picked it up and it fell apart super easily.
Now, was that her problem or your problem? Well, thank you very much. This was quite interesting. And I won't ever take a 15-hour bath, but if I ever get stuck in the middle of a lake, then I know I won't get too bigger. Thank you.